Hello friends, this is Soumitra here, and today we are interested to solve the problem modify sequence. So rather than going the problem description in detail, there is an array of n numbers. All the n numbers are non-negative numbers, and at any moment of time you can perform an operation on the array which decrements two adjacent elements of the array by 1. Each of them it decrements by 1. So now the task is this operation can be performed innumerable times on the array. So can we get a result of 0, 0, 0, that is all the elements in the array becomes 0 after performing this operation. And we have the liberty to perform operations as many numbers of times as we want. So here if you see down, we will see one of the example. In example this is 1, 2. So if we will decrement, no matter how many times we decrement these two numbers, we will never reach an array of 0, 0, because once we decrement, we will reach 0, 1. After that, decrementing will not help us to achieve the result of 0, 0. Similar way in this 2, 2, if we decrement each element of the array by 1, 1, then the array becomes 1 and 1. And if we again decrement each of the element, both these two elements basically by 1, then it will become 0. So hence we have achieved our desired goal. So before going into deeper, we will have a look upon some more complex examples. Then we will look upon the code. So let us look upon one more example. Here the input is given an array of non-negative numbers, that is 1, 2, 2, 1. So let's start iterating. So what we are here, let's try a greedy approach. What we do there is this: we'll try to make the last element 0 first. Okay, so last element is 1. So if you see, if I decrement both these two elements 2 and 1 by 1 and 1, they becomes 0 and 1. So now we are not interested into the last element because it is 0 already. So we are interested into the third element. So let's again make it 0 by again decrement 1, 1 from second and third element. So second element becomes 1 and third element becomes 0. In the similar way, now let's concentrate on second element. Let's try to make it 0. So it has become 0 and the first element has luckily also become 0. So now we have achieved a 0, 0, 0, 0. That is all the elements in the given array are 0, hence the output will be yes. Let us begin with one more input set. Here the input set is 2, 2, 2, 1. So again, forming the earlier ideology, let's try to make the fourth element as 0. So if we decrement both third and fourth element by 1 and 1 each, we can get 1, 0. Now the fourth element is 0. We are not interested. Let's try to make the third element 0. If we will decrement it by 1, then 2 will become 1. Second element will become 1 and third element will become 0. Till here everything is fine. Now let's try to make second element as 0. So we decrement first and second element as 0. Now no matter what you do, you can't make first element as, no matter what you do, you don't have any other elements before the first element, which is left with 1. So basically if you decrement any other thing, then the array will become non-zero, because the index from 2, 3, 4, they all are 0. Hence we are left with no option and there will be no way to make the whole array 0. So basically due to this one, the things are stuck here and we will print out that the output is no. let us go with one more case where the input is 2225. Now again let's try to make the last element, which is 5, as 0. So see what we can do. At any moment of time we don't want to reduce the array at such an extent that one elements become negative. Then in that case there will be no way to make that element equal to 0, because if you decrease a negative number by -1, it will again become a negative. It will never become 0. So hence, if you see third and fourth case, so third number is smaller than the fourth number, and if we decrease it by, we can at max decrease it by 2. So but then in the rightmost, that is the fourth element, will be left with 3. Hence the output will be no, because we can't figure out any solution in this case by trying anything. So before we move on further on the same thing, what we have realized is we are approaching the array in the backward direction, not in the forward direction. We iterate from the last element up to the first element, and we try to somehow make the last element as 0. So since at any point of time, if we make any element of the array as negative, then there is no way to make that particular index 0, because decrementing by a negative number will always give you a negative number. Hence, now we can approach and think it this way. This is getting more intuitive. We'll iterate the array from the backward direction, but if the just next element of the array, which is one element ahead in the array, if that number is lesser than the given number, so if I phrase it this way, so if the number at i-1th position is lesser than the number of ith position, then we can't make ith position number as 0, because if we make ith position number as 0, then i-1 will have to become negative, as the number at ith position is greater than the number at ith position is greater than the number at i-1th position. So here, this is a classic example here. So if you will see that 5 and 2 and 5, the number 5 is greater than the number 2. Hence, we can't reduce 5 to 0, because it will make the earlier number as negative, and we at any point making the number negative means that we have arrived to a position where there exists no solution. So now let us see one more interesting case. Here the number is 3, 7, 19, 15. So now rather than incrementing the number by 1, what we are saying is this: the number at ith position can be made 0, assuming we are traversing in the backward direction, if we reduce both I and i-1 number, both the number that indices I and i-1 by the number present at ith index. So here, if we reduce, we are going in backward direction, choose 19 and 15. So we want to reduce, make 15 0. Hence we have to reduce 19 to 4. So if we go ahead, it has become 4 and 15 has become 0. Now we want to make this 4 as 0. So we'll go again in backward direction, and 4 and 7 we'll see, and we'll make 7 as 3 and 4 as 0. Now first and second element, they both are equal, and if we reduce second element to 0, first element automatically becomes 0. Hence in this case output will be yes, because the solution exists. So now we have arrived at this conclusion that if the number at adjacent lower index is greater than the given number, then the solution, there is a chance solution exists. But if the number at ith index is greater than the number at i-1th index, and assuming that the number from I plus 1 up to n, we have marked all of them as 0. So i-1th I minus 1th and ith index we are looking at as I plus 1 up to n, they all have become 0. So we are figuring it out this way, that if the number at the position I minus 1 is less than the number at ith position, then there exists no solution. And if it is not the case, then we iterate till the end of the array, and I minus 1 keeps on changing. They starts getting decremented by 1, and once we reach at the first element, and if the first element is again left with non-zero number, then also there exists no solution. So let us see one more last case. The sequence is 3, 22, 19 and 15. Again we will start from the last index and will make the last index as 0. So we want to make 15 as 0. So 19 minus 15 will become 4. Now we are seeing again this particular pattern, that the number at I minus 1, which is the second location, is greater than the number at ith position. So solution still exists. We can reduce the number at I minus 1 position by the number present at ith position and make the ith position number as 0. So 4 will become 0 by then same logic, and 22 minus 4 becomes 18. Now this has driven us to a very peculiar situation, which is new in this own case, that the number at second position is greater than the number at first position. That is, number at ith position is greater than the number at I minus 1th position. Hence the output will say that there is no solution, because as we already told that we don't want the number at I minus 1th position to be negative, and we cannot play around with the number ahead of ith location, as they all have become 0. So in this case our ith location is 2, and number ahead of ith location, which is 3 and 4, they all have become 0. We cannot do anything with them, and the number at I minus 1th position is lesser than the number at ith position. 3 is less than 18. Hence we cannot reduce by 18, as it will give birth to the number at first position as minus 15, and we know that minus, if we reach any number reaches the state of minus 1, minus 2 or any negative number, then we cannot reach the solution no matter what kind of operations we apply. Now we will look at the coding standard of the given problem, which is again an accepted solution in our second part.